Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed first four questions from exercise 13.3. Hope it was clear for you all. In today's session, we shall discuss the remaining problems from exercise 13.3. Let's move on to the topic. Before starting the session, let's recall the formulae from the chapter surface area and volume. The first shape is cuboid. Length is represented by the letter L, breadth is represented by B, and height is represented by H. Then the volume is L into B into H. Lateral surface area is 2H into L plus B, and the total surface area is 2 into LH plus BH plus LB. Next shape is cuboid. The side of the cuboid is represented by the letter A. Then the volume is A cube. Lateral surface area is 4a square and the total surface area is 6a square. Next is a right circular cylinder. The height of the cylinder is represented by the letter H and the radius is represented by the letter R. Then the volume is pi r square H. Lateral surface area is 2 pi r H and the total surface area is 2 pi r into H plus R. Next one is a right circular cone. The height is represented by H. Radius is represented by the letter R. And the slant height is represented by the letter L. Then the volume is 1 by 3 pi r square H. Lateral surface area or curved surface area is pi rl and the total surface area is pi r into L plus R. Next shape is sphere where the radius is represented by the letter R. Then the volume is given by the formula 4 by 3 into pi r cube. Curved surface area is 4 pi r square and the total surface area also the same formula 4 pi r square. Next shape is hemisphere. Like the previous one sphere, here also radius is represented by the letter R. Then the volume is 2 by 3 pi r cube and the curved surface area is 2 pi r square and the total surface area is 3 pi r square. Exercise 13.3, fifth question. A container shaped like a right circular cylinder having diameter 12 cm and height 15 cm is full of ice cream. The ice cream is to be filled into cones of height 12 cm and diameter 6 cm having a hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. Let's go through the question and just define what are the things given to you here. Let's identify the things which are given to you. A container shaped like a right circular cylinder having diameter 12 cm and height 15 cm is full of ice cream. Means a cylindrical container is having full of ice cream. The dimensions of the container is given to you here. Dimensions means here it is diameter 12 cm is given. From here we can calculate the radius. Height of the cylindrical container, that is 15 cm also given to you. And we are making ice cream cones. We are filling the ice cream cones of height 12 cm and diameter 6 cm having a hemispherical shape on the top. You might have seen the ice cream cones, means the bottom portion is conical and on top of the cone there is hemispherical shape. So that is the way the ice cream is filled. Here, collecting ice creams from this cylindrical container and we are filling these ice cream cones. Dimensions are given to you, height 12 cm, diameter 6 cm. Question is, find the number of such cones which can be filled with ice cream. How many number of cones or how many number of ice creams we can fill by collecting from the cylindrical container. That is what the question. So let's visualize the question. So the cylindrical container which is having 12 cm diameter and height 15 cm is full of ice cream. This container is having full of ice cream. And from here we are collecting the ice cream and filling the ice cream cones. Means bottom portion is conical in shape and top is hemispherical shape. This is the way the ice cream cone is filled. And the height of the conical portion is 12 cm and the diameter of the circular portion, that is 6 cm. Here we are asked to calculate how many such cones can be filled by using ice cream by using the ice cream in the cylindrical container. So Here there are three shapes we can easily identify. One is the cylinder, here is conical portion, and here is hemispherical portion. So these three portions diameter we can write, sorry, dimensions we can write. First one is the cylindrical portion. Radius we can say that is diameter by 2, that is 12 by 2, that is 6 centimeter. Height it is given to us 15 centimeter. Then we can go for the conical portion of the ice cream, that is radius again diameter by 2, that is 6 by 2, 6 by 2 is 3 centimeter, and height is given to you 12 centimeter. Again one more portion is here, that is hemispherical portion. So for hemisphere, radius diameter by 2, that is 6 by 2, that is 3 centimeter. There is only one dimension in hemisphere, that is radius, so 3 centimeter we have got. Now volume of the cylinder. So here this cylinder is having full of ice cream. So let's calculate how much quantity of ice cream is there in this container. That means that is equal to the volume of the cylinder. So volume of the cylinder formula we know pi r square h. So pi into radius of the cylindrical container, that is 6, square into height is h. So pi you no need to substitute now. Let's keep it. That is pi into 6 square is 6 into 6 into 15. So when you multiply 6 into 6 into 15, we will get as 540 pi. So I request all of you to multiply this one on the right side of your notebook. Please do not copy. 6 into 6 into 15, you will get as 540 pi. Next, we will go for volume of ice cream cone. So volume of ice cream cone in the sense, there are two shapes are added here, two solid shapes. One is conical portion, another one is hemispherical portion. So that means volume of cone plus volume of hemisphere. So volume of ice cream cone, this full shape is called the ice cream cone. So this ice cream cone is having conical portion and hemispherical portion. For finding the volume of ice cream cone, we must add these two shapes volume. So volume of cone plus volume of hemisphere. 1 by 3 pi r square is the volume of cone formula, and the volume of hemisphere formula is 2 by 3 pi r cube. So let's substitute here. 1 by 3 into pi into r square is 3 square into h of the cone is 12 plus 2 by 3 pi r cube, that is 2 by 3 into pi into r is 3, so 3 cube, that is equal to here 1 3 and 1 3 will be cancelled, here one more 3 balance, 3 into 12 is 36, so 36 pi plus here 1 3 will be cancelled, remaining 2 3's will be there, so 9, 3 square is 9, 9 into 2 18, so 18 pi, that is equal to 36 plus 18 pi is 54 pi. So now we have got both the volumes. Volume of cylindrical container also we are having 540 pi, and the volume of one ice cream cone is 54 pi. Here we have to find out the number of cones, how many such cones can be prepared. So number of cones will be volume of the cylinder divided by volume of one ice cream cone. So volume of the cylinder we have calculated here, that is 550 pi divided by 54 pi is the volume of ice cream cone. So here pi and pi can be cancelled, and 54 and 540 we can cancel and write it 10 times. So number of cones is equal to 10. So number of cones is 10. That is the answer. Next we shall discuss the sixth question. How many silver coins 1.75 centimeter in diameter and of thickness 2 mm must be melted to form a cuboid of dimensions 5.5 centimeter by 10 centimeter by 3.5 centimeter? How many silver coins? Silver coin dimensions are given to you. Silver coin means it is in cylindrical shape. Diameter is there, thickness is there. Means from here we can calculate the radius, and the thickness we can consider as the height of the cylinder. And a particular number of silver coins we are melting and forming a cuboid of this dimension. We are asked to find out how many silver coins we are melting to form this cuboid. So once again, the question what it is mentioned here is a particular number of silver coins of this dimension we are melting and recasting or forming a cuboid of this dimension. So we are asked to find out how many silver coins we are using to form this cuboid. So let's visualize it. This is a coin, cylindrical in shape. Diameter is 1.75 centimeter and height is 2 millimeter. You must note this is in centimeter, this is in millimeter. We must change one unit. Means both should be in same unit. This one we are several number of such coins. We are melting and forming a cuboid. Dimension 5.5 by 10 by 3.5. So the question is, how many such cylindrical or coins we are using to form this cuboid? Let's write the dimensions given to you. That is cuboid, that is length is given to you 5.5 centimeter, breadth is there 10 centimeter, and the height is there 3.5 centimeter. And next is for a coin. It is quite clear. Coin is in cylindrical shape. We have the radius diameter by 2, that is 1.75 by 2 centimeter. Here this is a decimal value, so we will go with a different approach here for easy calculation. So we will just avoid the decimal and we will use the fraction. Means 1.75 we can write it as 175 by 100. 1.75 we can write it as 175 by 100. These two remains the same in the denominator. We changed only this 1.75. 1.75 we have written as a fraction, that is 175 divided by 100. After decimal 2 digits, so we remove the decimal portion and divide with the 100, means 2 zeros. Next is height is 2 millimeter. As I mentioned before, this is in millimeter. All other units are in centimeter. So we have to change this millimeter to centimeter. Millimeter to centimeter means we have to divide with 10. So 2 by 10 centimeter. Then volume of the cuboid, we will use the formula L into B into H, 5.5 into 10 into 3.5. As I mentioned before, we will not use the decimals here, we will use the fractions. That is what our approach. So 55 into 10 into 35. Here after the decimal 1 digit, here after the decimal 1 digit. So total after the decimal 2 digits. Divided with 100, 2 zeros. 2 digits means 2 zeros. So 55 into 10 into 35 divided by 100. So we have removed the decimal portion. Then here 1 zeros we can cancel. 55 into 35 by 10 will be there. So 55 into 35 by 10 centimeter cube. No more calculation. We will do further calculation at last. So denominator with a 0, it is not a problem. With multiples of 10 is not a problem. We can easily calculate later on. Next is volume of one coin. Volume of coin, as I said before, it is a cylindrical in shape. So the formula is pi r square h. Here pi value we have to substitute because keeping pi is of no use. Previously we use only L into B into H. There is no pi, no way of cancellation. So you have to substitute. That is pi into 175, that is r we have, r is here 175 by 2 into 100 the whole square into h is 2 by 10. So let's substitute the value of pi also and rearrangement also. Pi is 22 by 7. So 22 is in the numerator, 7 is in the denominator. We are writing all the numerator and denominator together. So 22 by 7. Here 175 square in the numerator means 175 into 175. Into there is one more 2 in the numerator we have written, divided by denominator in the pi there is a 7 balance, so we just put 7 into 2 into 100 2 times into 10. We'll go for calculation. 7 and 175. 7 and 175 if you cancel it will come here. 7 2s are 14. 7 2s are 14. In 17 remaining 3 balance, so 35. 35 means 5, so 25 will come. Then next is 2 and 2 cancelled. Next is 2 and 22 we can cancel and write 11 times. That is equal to 11 into 25 into 175 divided by denominator is having here 2 0, here 2 0, here 1 0, total 5 zeros. 1 2 3 4 5 means 1 lakh. Let it be here because the denominator is having a multiple of 10, easy for us to calculate. Let it be same. Next we have to calculate the number of coins. Number of coin means volume of the cuboid. This is a shape we are making. Volume of the cuboid divided by volume of one coin. So both we have calculated and kept. We will substitute 55 into 35 divided by 10, that is the volume of cuboid. Next is volume of one coin is here 11 into 25 into 175 by 1 lakh. So let's go for calculation. This is the numerator and this is the denominator's denominator. So this will come here in the numerator. That is 55 into 35 into this 1 lakh divided by this will join with the denominator. That is 11 into 25 into 175 into 10. Once again, 55 into 35. This denominator will come to the numerator because we are multiplying with the reciprocal. This will go to the numerator. This will come to the denominator. So 55 into 35 into 1 lakh divided by 11 into 25 into 175 into this 10. That is, we will go for calculation. Here 11 and 55, 5 times will come. Then this 5 and this 175, we can go for 35 times because 5, 15. Remaining 2 balance. 5 3s are 15, 3 is written. Remaining 2 balance 25. 25 means 5 times, so 35. Then that 35 and this 35 can be cancelled. Then here 25 and 1 lakh. 25 and 100 will go 4 times. And after 100 there are 3 zeros. 1, 2, 3. So that 3 zeros put 4,000. 25 and 1 lakh, when we divide, we will get 4,000. And this 4,000 and this 10, 1 0 we can cancel. We will get as 400. So the number of coins are 400. This is the answer. Next we shall discuss question number 7. A cylindrical bucket 32 cm high with a radius of base 18 cm is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. The height of the conical heap is 24 cm. Find the radius and slant height of the heap. Cylindrical bucket. Dimensions are given. Height is 32 cm. Base is 18 cm. Is filling with full of sand. So this bucket is filling with full of sand and we are just dumping it back to the ground and form a conical heap of sand. A conical shape we are forming. When this bucket of sand is dumped back into the ground means we will get a conical shape. So that is called a conical heap of sand. Height of the heap is given to you 24 cm. We are asked to find out the radius and slant height of the heap. Let's visualize the question. A bucket which is having 18 cm radius and 32 cm height is full of sand, filling with full of sand, and we are just dumping it back to the ground and form a conical heap of sand. Means when this sand, when we dump back to the ground, we will get a conical shape of heap of sand. Height of that heap of sand is 24 cm. We are asked to find out the radius and the slant height. So radius we can take it as R and slant height will be taken as L. So the dimensions we can write. Cylindrical bucket radius is 18, height is 32 cm, and for the conical heap of sand means conical shape, height is 24 cm. We don't know the radius and we don't know the slant height. So let it be R and L. So the sand what is there inside this cylindrical bucket only we are using to form the conical heap. Whatever sand is there inside this inside this cylindrical bucket means before it was in cylindrical shape. When the sand is inside the cylindrical bucket, the shape is cylindrical, and that same sand only we are using to form a conical heap of sand. So both the volumes are same. Whatever quantity was there here inside the cylindrical bucket, that quantity only we use to form the conical heap. So both the volumes are same. Since the sand in cylindrical bucket is empty to make a conical heap, volume of cylindrical bucket is equal to volume of heap, conical heap. So volume of cylindrical bucket we know pi r square h. Substitute the values. Pi into r. R is 18 square, h is 32. Volume of cone is 1 by 3 pi r square h. That is 1 by 3 into pi into r. R we don't know. R square into h is 24. Here both the side pi we can cancel. And here 3 and 24 we can cancel 8 times. So right side we are having r square into 8. From here r square we can calculate. This 8 we can bring to the left side. Means denominator. Because here multiplication r square into 8. When it comes to the left side it comes division. Divided by. So 18 into 32 by 8. Here easy cancellation is there. 8 and 32 we can cancel 4 times. So we will get r square is equal to 18 into 4. 8 and 32 we cancelled, we get 4. From here r we can calculate 18 into 4 because no need to multiply because you can see here two quantities same number, so easily we can find out the square root. 4 also a perfect square we can easily find out. So 18 into 18 into 4, square root taking time, we will get 18 into 2. Out of this 18, 118 came out. Square root of 4, when it came out, it comes as 2. So 18 into 2, that is equal to 36 centimeter. So radius we have got. We will go for finding out L. L, we know the formula. L square is equal to h square plus r square. So L square is equal to h, we know h is 24. So 24 square plus r is 36 square. So that is equal to 24 square is 576, 36 square is 1296. Up to 25 we might have by hearted. 36 we have to multiply and calculate. 36 into 36, 1296. That is equal to 1872. When we add these two, we will get as 1872. So L is equal to root of 1872. Here two way we can calculate the square root. Either we can go for estimation or we can go for factorization. So factorization is the best one. Factorization in the sense either you can go for prime factorization if you don't know the estimated value, or else we can go with the bigger numbers. Here I am going with the bigger numbers, that is L is equal to root of 12 into 12 into 13 will be coming. If you don't know this one, just go for prime factorization and make a group of 2 and then calculate. Whichever way, it's not a problem. L is equal to root of 12 into 13. So from here, this out of these two 12, 112 will be coming out. So 12, 13 is a prime number, so it remains the same root inside the square root. So L is equal to 12 root 13 centimeter. That is the slant height. Next, we shall discuss question number 8. The question is, water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? Here, a canal is in the shape of a cuboid. So, water in a canal. Water in a canal means since the water is inside the canal, the shape of water which is flowing also in cuboidal shape. So 6 meter wide and 1.5 meter deep. Depth and width are given to you. Is flowing with a speed of 10 km per hour. So here we will take it in another way. This speed means in 1 hour the water will flow at 10 km. So in 1 hour the water will flow 10 km. How much area will irrigate in 30 minutes if 8 centimeter of standing water is needed? So how much area will it irrigate? The water will be used to irrigate in 30 minutes if 8 centimeter of standing water is needed. The height of that particular quantity of water is 8 centimeter. So let's visualize the question. This is the shape of a canal and inside water is there, and this is like a cuboid. Breadth is given to us 6 meter and height is given to us 1.5 meter. And let's write the given measurements. Canal is in the shape of a cuboid where breadth is 6 meter and the height is 1.5 meter. One more condition is given to us, speed of canal, that is 10 km per hour. This one we will use it in another way. That means water will flow in 1 hour 10 km. In 1 hour water will flow 10 km. Means we can consider this as the length of the canal. Length of the canal or length of the water which it is flowing. So the speed of the canal is 10 km per hour, means in 1 hour water will flow 10 km. We will consider this 10 km as the length of the cuboid. So we know volume of water flown in 1 hour means that will be equal to the volume of the cuboid, that is L into B into H. Since we are taking this one as volume of the cuboid because the canal is in the shape of a cuboid. So L into B into H. So we will substitute the values. Length, as I said before, length is 10 km, breadth is 6 and height is 1.5. So 10 into 6 into 1.5. And here this is it 10 km. The unit is in kilometer, but all other units are in meters. So this 10 km we have to convert into meter, means we have to multiply with 1000. So 10 into 6 into 1.5, L into B into H we have substituted. Then we have changed the unit also. This 10 km we are changing into meter by multiplying 1000. That is, here little bit of calculation. Here, as I said before, decimals we have to reduce. Number of decimal values we have to reduce. Here 1.5 is in decimal form. We can multiply this 10 and 1.5. We will get the answer as 15. The remaining quantities, okay, there is not a problem. 6 and 1000. So this 1.5 and 10 we can take together and we can write it as 15. The remaining quantities 6 and 1000 as it is we will keep. So 6 into 15 into 1000 meter cube. This is the volume of water flown in 1 hour. Next, volume of water flown in 30 minutes. That is what we have to calculate. How much area will it irrigate in 30 minutes? Then means we need how much volume of water will be available in 30 minutes, will be flown in 30 minutes. So water flowing in 1 hour is this much quantity. Volume of water flown in 30 minutes is half of this 1 hour quantity. So 30 minutes is half of 1 hour. So the volume of water also will be half. That is equal to 6 into 15 into 1000 divided by 2. So that is equal to this 2 and 6 we can cancel 3. So 3 into 15 into 1000 meter cube. This is the volume of the water flown in 30 minutes. So volume of water flown in 30 minutes. This volume of three-dimensional shapes, there is a formula, base area into height. So that formula we are using. Volume of water flown in 30 minutes. This volume of water only we are going to use in irrigation purpose. So volume of water flown in 30 minutes is this much, 3 into 15 into 1000. And this left side we will change the formula. That is volume formula is area into height. Base area into height means area to be irrigated into height is equal to 3 into 15 into 1000. Then this area need to be irrigated. That one only we have to calculate. How much area will it irrigate? That only we have to calculate. Height of water is given to us. That is 8 centimeter. That we have to multiply here. So area into 8 is equal to 3 into 15 into 1000. So area into, this is in centimeter. All other units are in meter. So centimeter to meter conversion is divided by 100. So area irrigated into 8 by 100 meter is equal to 3 into 15 into 1000. Here area irrigated is equal to, just cross multiply, this 100 will come in the numerator, this 8 will come in the denominator. So 3 into 15 into 1000 into 100, this 100 will come here in the numerator, divided by this 8 will come here. Meter square, that is equal to 3 into 15 into 1000 into 100 divided by 8 meter square we have calculated. And here little bit of calculation. Here this 1000 and 8 we can cancel. We will get it as 125. 3 into 15 into 1000 into 100 by 8 we have got. And here 8 and 1000 we will cancel. And 125 will get. That is equal to, when we multiply 3 into 15 into 125 into 100, we will get as 562 500. That means 5,62,500 meter square. 5,62,500 meter square. This is the answer. But here this is a little bit of huge quantity, so we can convert this unit. This is in meter square. We can convert it into hectares. So that means we have to divide it with 10,000, because we know the relation 10,000 meter square is 1 hectares. So 10,000 meter square is 1 hectares. So this meter square we want to convert into higher unit, that is hectare. So we have to divide with 10,000, because meter square is a smaller unit and hectare is a bigger unit. From smaller unit to bigger unit conversion, we will be dividing with 10,000. So when we divide this one with 10,000, here in the denominator 1, 2, 3, 4 zeros, means we will put the decimal 4 places from the right. So 1, 2, 3, 4. Here we have to put the decimal. So 56.25 hectares we can irrigate by using this 8 centimeter standing water within this 30 minutes. That is the answer. Next, we shall discuss the 9th question. A farmer connects a pipe of internal diameter 20 cm from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. If water flows through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? Here, a farmer connects a pipe of internal diameter. A pipe she is connecting, internal diameter is 10 cm. And here you must note the unit. This is in centimeter, the other units are in meters. And it is connected to a cylindrical tank in her field. Dimensions are given: 10-meter diameter and 2-meter deep. If water flows through the pipe at the rate of 3 km per hour, this also speed. Speed is given to you. Just like the previous question, we will not consider it as a speed. We will think in a way that in 1 hour, the water will flow 3 km. Means we will consider it as the length. In how much time will the tank be filled? The time taken to fill the tank we have to calculate. Let's visualize the question. There is a tank which is in cylindrical shape. Diameter is 10 meter, height is 2 meter. She is connecting this one with a pipe of 20 centimeter diameter. We are asked to find out when the water will flow, when the water is flowing with this a particular speed through this pipe, how much time it will take to fill this tank. That is what the question. For the pipe, the dimensions are given. Radius is 20 by 2, that is 20 centimeter by 2, that is 10 centimeter we will get. As I said before, here the unit we have to change. This is in centimeter, the other units are in meter. So we have to change this centimeter to meter. Centimeter is a smaller unit, meter is a bigger unit. So we have to divide with 100. So centimeter to meter conversion is divided by 100. So 10 by 100 meter. Here 1 0 we can cancel and we can write the remaining as fraction 1 by 10 meter. Next is for the tank. Dimensions are given. Radius is 10 by 2, that is 5 meter, and height is 2 meter. Let's calculate the volume of this tank because we are just going to fill this tank. So we must know how much capacity is there. So volume of the tank is, we know it is a cylindrical in shape. The formula is pi r square h. So pi into radius is 5. 5 square means 5 into 5 into h. H is 2 meter. So pi into 5 into 5 into 2 meter cube is the volume of the tank. Next, by using this rate of flow, we will calculate the volume of the water flown in 1 hour. So since the water is flowing through this pipe and coming into the tank, so the speed of the water which is flowing through this cylindrical pipe only given to us 3 km in 1 hour. So we will consider it volume of water flown in 1 hour is equal to, since the water is flowing inside a cylindrical pipe, the shape of the water also cylindrical only. So the volume is pi r square h, and here height we can consider as the length. Length means here 3 km in 1 hour. Here we are going to calculate the volume of water flown in 1 hour. So in 1 hour 3 km it will flow. So this 3 km we can consider as h. Here pi into radius we have calculated 1 by 10 into 1 by 10 into 3 km. 3 km we have to change into meter because all other units are in meter. So 3 into kilometer to meter conversion is 1000. Multiply with 1000 meter cube. This is the volume of water flown in 1 hour. So time taken to fill the tank is equal to the volume of this tank. Means here only we are going to fill the water. So volume of this tank divided by volume of water flown in 1 hour. That is equal to volume of the tank divided by volume of the water flown into the tank in 1 hour. Both we have calculated. Let's substitute it. So volume of the tank is pi into 5 into 5 into 2 divided by volume of the water flown in 1 hour. So the unit is here hour. 1 hour is pi into 1 by 10 into 1 by 10 into 3 into 1000 hour. Here because the volume of water flown in 1 hour we have included. So the time unit what we are going to get here is in hours. That is equal to, here pi and pi we can cancel. Then numerator 5 into 5 into 2 is there, and here denominator are there 10 and 10. This will come to the numerator. So 5 into 5 into 2 into these two tens will come in the numerator. Divided by, in the denominator pi is gone, 1 and 1 multiplying by 1 only, 3 into 1000 will be coming in the denominator. That is equal to, we can just do the calculation. Here 2 zeros with can be cancelled with this 10 and this 10. So here 1 0 can cancel, here 1 0 can cancel. So 2 zeros out of 1000, 2 zeros cancel. And here 5 and 2, 5 into 2 multiplying time we will get 10, and that 10 and this 10 also can be cancelled. The balance is now 5 and 3. Numerator is 5, denominator is 3. So we will get the answer as 5 by 3 hour. So this is not in a proper format. So we will change this hour into minutes. That is equal to 5 by 3 into hour into minute conversion is multiply by 60. So 5 by 3 into 60 minutes. Here 3 and 60 we can cancel. Then we will get as 20. 3 2s are 6. So we will get 20. So 20 into 5 we will get 100 minutes. So the tank will be filled in 100 minutes. So in 100 minutes the tank will be filled. Dear students, today we have discussed the last 5 questions from exercise 13.3. I request all the students to go through this video very carefully and solve these questions independently in a sheet of paper. While solving, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.